Hi, everybody. Welcome back to the Astro Imaging channel. I'm Alex, and we're here with Olga and Terry, and Eric's in the room, and of course, Bob Denny's here. He's been doing a lot of work on Alpaca. He's been trying to make how when Spock and Kirk go visit a foreign planet, and they've got to talk to everybody on the planet, even though they really only speak English because everybody in the universe speaks English. Well, Bob has made that possible for. Um, um, Machines and equipment that we use for astro imaging, and he's going to tell us a little bit about about that, what we need to know about it, and the future of this kind of intercommunication among devices and stuff like that. He's been updating it since the last time we saw him, and he's got a lot to tell us. Before we go there, though, I want to share my screen here, and let's see. Oops, I got the wrong button. I got the wrong set of three dots. Share screen, my entire screen, and here we go. First thing I want to do is go to the calendar, and that's probably a little bit too small for you to read, but it helps me that I can take care of here. Tonight we got Bob and uh, Professor Vanderby is going to be here next week to talk to us, and that's going to be kind of cool. He's going to tell us about Hertzsprung-Russell diagrams, and he's taken a pretty interesting image of it and related it to some, and he's going to tell us how he pulled all that off. And then Tim Connolly's coming in the week after that because I don't know about you, but it's getting cold where I am. I mean, it's not cold like where many of you people are, but Southern California does get its cold. So Tim Connolly, who's been here before, is going to tell us a little bit about that. We take a holiday off and on the 29th, and then one of the premier lunar imagers is going to be here on January 5th. Robert Reeves is going to tell us about lunar imaging and stuff. And Sam Ropert on the next week is going to tell us about the OBSTEC Observatory. Bill Clugston's coming in, and I really like the fact that Bill's here. He's one of us. He's one of the people on the Astro Imaging channel, one of the people that watch regularly. He's going to tell us about imaging with disabilities a little bit. We all think it's pretty easy to do what we do when we can move around a little bit, but we have to make accommodations. And maybe you need accommodations when you're imaging. Maybe you need to change things around the way you do stuff. And he's going to tell us a little bit about that. And even if you don't, there's probably people in your club that need a little bit of assistance, and maybe you can get some ideas for how to help folks out when things aren't as easy for them as they might be for you. What's his name? That old Warren Keller's going to be over here. He's going to be visiting us on the 26th of January. As you know, Pix Insight's done some updating lately, and since Warren is one of the big gurus in Pix Insight, we asked him to come on in and tell us what's new. He's got some new stuff to teach with Pix Insight, and he's been working pretty hard with the new batch processing script, which allows one to um, analyze the different frames and take the best pictures and weight them differently, kind of automatically, which is kind of cool. Um, the week after that, well, we are in America, and so we have to take the day off for Super Bowl Sunday. And then we've got some open dates, and Terry's going to be here for observatory construction. We do have a few people that we're asking to come on in about observatory construction and some other things that they're going to tell us some of their stories. We are always interested in getting ideas, and some of you guys have been coming up with some great ideas for what we need to do in the way of imaging and present topics for you. But we got to get presenters, and you are the people that should be here interested and hopefully telling us what if you could show us some ideas that you have about and you could come on in and do some presenting. Please contact us at the astroimagingchannel.com. There's one other thing I want to talk about, and where is there we go. Um, the Astroimaging Channel website has been hacked, as you may or may not know. And so if you were to go there, well, we fixed it so that you're just going to get a sign that says we're under construction. Please be patient with us. We have to rebuild the whole darn thing because somebody's having some fun with it. And so please be patient. When you go to the YouTube, be sure to ask your questions over there in that one column where you can see everything. There's lots of questions, lots of comments. There's a place to make suggestions. There's ideas that you can give us. There's also a place to subscribe. We really need subscribers. I don't understand it all, but apparently the more subscribers you get, the more power you can get on YouTube to reach out to more people and things like that. And it really would help us if you would subscribe down there in the corner. You can learn how to subscribe to the YouTube channel itself. So please do that. Okay, enough of the preliminaries. If you've got any questions,
I have a couple of things to say.
I would like Tolga to say something.
So somebody asked about our schedule. So currently we're posting everything on Facebook. So if you have a Facebook account, you can go to, there's an Astroimaging Channel page. Also, there's an Astroimaging Channel group. And the calendar is posted on both of them. And there's one more thing. And I will also put the calendar, link to a calendar under this video. So since we don't have a website, we could use this video as a reference. And then the last thing is about Deep Sky Chile. Instead of Sam, Vincent Suk is going to come to do the presentation for Deep Sky Chile. So that's it.
Okay, cool. We ready to go, Bob?
We are.
Okay, take it away, dude.
Okie doke. Hold on. I'm going first to... Good evening, everybody. I'm Bob Denny. I have a lot to talk about. I'm going to dive in, but first I want to thank these guys for giving me a chance to give you an update on Alpaca, ASCOM Alpaca. I'm going to make this a kind of comprehensive, total overview of ASCOM itself, because I know there's a lot of people here who don't appreciate the concept of an interface and modular software and that sort of thing. So I'm going to go through the whole thing. I have an hour to do it. It's going to be brisk. I'm going to be stopping periodically for a 5-minute Q&A, and I'm going to rely on these guys to pick questions to give me by vocally. And I'm not going to be looking at the YouTube thing. It's too distracting. So with that, let me get my screen shared and start up here. Just a moment. All right, I have one other thing to do here. That is to put me down here in the corner so you can at least see me and see me wave my hands. And if I'm in the way of some of the titles, well, I'm sorry. All right. So let me give a little background about me. I'm the guy who originally came into astronomy back in 1999 with the idea of ASCOM, and we'll explain what that is in much more detail, but this was something that is something from computer science years ago, and I just basically brought the concept into astronomy to open things up. Have not been a developer for ASCOM since 2009. What I do is evangelize it, and I talk to people. I try to keep the ball rolling and the buzz going, but I'm not a developer since 2009. I'm just another astronomy app developer. My software, ACP, is an ASCOM client software, and I use that to get to the devices that I control. All of my ASCOM activities are voluntary, and I'm not compensated for them. So another important piece of info here is that I am not here for a standards war. I'm here to tell you about ASCOM and about Alpaca. ASCOM's a successful standard and has been for 20 years. It's pretty universally used on Windows. And I'm going to tell you how that's being extended into the Mac, Linux, Android, and iOS area. And so that's my job tonight, is to give you some background, and then tell you where it's going in the future. I'm hoping that tonight's talk will kind of light your fuse a little bit. You know, light bulb might go off. Oh, that's what it is. It's not just ASCOM that's broken because, you know, it must be ASCOM. I can't talk to my camera. It's that damn ASCOM again. No, it's usually your USB or, you know, something like that. So I just hope the light bulb will go on. And the idea here is for you to better understand how all your equipment works together so that you can find the problem and then go to the right place to get the problem solved. That's really the bottom line. So how am I going to do that? First thing I'm going to talk about is the driver client concept. And this is one of those light bulb concepts. I'm not going to spend a whole lot of time on it, but it's really important to understand since you're using modular software. This is a key thing. And it's been around for 40 years in computing. It's not my idea. Second, the actual interfaces between the modules. What are the principles on which ASCOM is based? And then some history from the beginning to today. Then I'll talk about Alpaca. Now that you've got, you know, a theoretical and fundamental basis of understanding, you'll be able to better understand how Alpaca makes that concept spread to the other platforms and other languages as well. What the current status is, and then if we have some time, we'll do a wrap up. And actually, the status will also is pretty much optional as well if we run out of time. But I'm looking right now. I'm already, how'd we get 13 minutes? Oh, that's right, because there was 10 minutes of you guys. So, all right. So in the beginning, back in, you know, oh, I'm sorry. This is the first. Yeah, I skipped a slide, didn't I? Yep, I sure did. All right, I was here. Hold on here. I'm sorry. I pushed a. This was where I was. Now, I went from here to here. I'm going to be answering questions periodically. And these slides will come up and there'll be 5 minutes. So if you have questions, type them in so that Alex and the guys can see them and pick which questions they like the best, and then they can ask me and I'll try to answer them, but I want to keep it down to 5 minutes. I don't want to get trapped into a long discussion and run out of time because there's a lot to cover. So on the agenda, part 1 would be this driver client architecture. I'm going to try to make some of these things clear. I will do my best. And this is where, if you have a question, I'm going to stop at the end of this section and try to clarify anything that I didn't make clear enough. So, number one, we all use modular systems. You can imagine the jet with a huge black box in the belly with 1,000 Canon connectors and wires running to the toilet, the jets, the lights, the seats, the instruments. Nah, that's not how things are done. That it would be impossible to troubleshoot and be just awful. So everything is a modular system. In astronomy, you have even multiple pieces of software, and then they talk to multiple devices. So you have all these bits and pieces that are talking to each other. Even if you're using one program that does it all, you still have modules that you're talking to because there's software in the mount, there's software in the focuser, and all of that. We all use modular systems, period. So just get that. The keys to success in a modular architecture are, number one, what are those interfaces? What's the thing that connects this block with that block? That interface is the key. If you get those wrong, you're not going to go anywhere. Any system with bad interfaces is doomed to failure in the long run. So the interfaces are the highest technical risk. Secondly, the connectivity between the modules is another very important thing. How do these things talk to each other? Serial, parallel, remember that? And the old Meade parallel cameras? USB, which I think we can all agree is the beast from hell. TCP/IP, Ethernet, Wi-Fi, Bluetooth, whatever. Okay, so we have connectivity also. And we also between the software the programs on a system, at least on Windows, we have a connectivity solution provided by Windows called COM, or local procedure call, LPC or COM. So there's that. On other systems, different, it's between libraries, and you have glue libraries and things like that. There are no other operating systems with a built-in thing like COM and LPC. The closest thing would be to use TCP/IP. So, and that's used between programs on other operating systems. So what ASCOM is, so let me just stop right there and say that the interface, what we're talking about, and I'll expand on this in a minute. The interface is the key. So what ASCOM is, fundamentally, it's an interface design. It's how the things talk to each other. And it's historically used this COM and LPC for communications and for language neutrality. On Windows, if you use COM, you can talk in the native syntax of 20 different languages. And you could write drivers in like 6 or 7 languages. It's not a single language thing. So that's what made it really successful in the early days. We had people with MATLAB talking to telescopes. So what Alpaca does is it takes those same interfaces and extends them to Linux, OS X, Android, and iOS. And in that case, it means now with Alpaca, you have platform neutrality and language neutrality, because the glue, instead of COM LPC, it's REST, and I'll be more specific about that. And everything supports REST. It's everywhere, even on little tiny processors. So I hope that gives you a clue. I'm going to try to get this. Come on. Is that the next one? Yes. I don't know why I'm having difficult with this. So in the beginning, we had this kind of situation. And let me just try to point out architecturally. Now I'm going to get into some architecture issues. Try and follow me through here. In the old days, for a program to support a mount, you had to write code for that mount. And then your program has to write different code for this mount and different code for that mount. Can you see my, I hope you can see my cursor. Anyway, code A for A type mount, code for B type mount, code for C and D. So now your program has special code for each one of those mounts, for a mead, for a whatever, okay? That's in the old days. So what happens here is you have unrelated people who are responsible for the use of that mount. You have the guy that's writing the application, and he writes this control code up here, and then we have the people who develop the mounts, and they have firmware and whatever goes between these two, the type of communications between the two of them. That's special. It's XYZZY KLG for this one, and XXXYYY or for number B, and all of that. So the app must support every mount out there. What happens when a new one comes out? Now the app developer has to write more code, right? And what happens when somebody drags a mount out of the garage and wants to use it with this app? Oh, yeah, I got to write code for that too. So it's kind of a mess. That's the old days. But wait, there's more. Jump 2 slides on that time. No. So now what happens with multiple applications? We have SkyWizard. The poor developer who develops SkyWizard has to write code for every one of these 4 mounts and all the other ones, right? Then somebody comes along, oh, I want to develop SkyView. Well, now I got to write code for each one of these mounts. Or Amazing Night Sky, that guy has to write code for each of those mounts. Can you see how this cannot scale? This was the situation that when I came into astronomy in 1999, I looked out there and I said, the astronomy software market cannot possibly grow because there's no driver client architecture. And that was totally, that was before I ever even started with ACP. I knew there was no way I was going to get into writing mount code for everything out there. Impossible. And neither would anybody else. If you talk to the guys who write SGP, they'll tell you the same thing. Their software would not exist were it not for ASCOM standards. They have had to bend over for some of the camera manufacturers, but largely SGP depends on ASCOM because they didn't have to write these things. But wait, there's more. It gets worse. What happens when there's a problem with Mount B? You can see I kind of cross-hatched them here. Whose problem is it? Is it the code that George, who wrote this particular application to support B? Is that where the problem is? Or is it in the B mount itself? Who knows? Why won't my B scope slew currently or correctly? Where's the problem? Who knows? So you get into this finger pointing thing. No, it's his fault. No, it's his fault. Well, he didn't tell me that I had to send this code 20 milliseconds after the last one. That wasn't part of the spec. So, and you get into a mess. So that there's that issue too. So enter a standard where you have for each of these applications one universal connection. One thing, one mount connection. That's it. So from my point of view, as an application author, I make calls in my natural language of my own software in its natural language. I make very simple, straightforward function calls, and it does not matter which mount I'm talking to. They're all the same. So on the right-hand side, you see the old B mount quits. I have 20 or 100 or 500 people using my software, and somebody says, hey, my B mount's not working. Well, you know what? If the problem was in my universal software, I'd have people with pitchforks and torches at my gates. Hey, everything's broken. So you can be pretty sure that the problem is in the mount or its driver, and I'll get into that in a minute. So it makes it easier to tell where the problem is, and this is where I'm leading with this, is the driver client architecture makes it easier for you as a system owner and operator to help with faults and to prevent finger pointing. If the application is running with all the other mounts out there and it's not running with this mount, you're pretty sure, really sure, that the problem's with the mount, because you're speaking a standard universal protocol or interface, right? That's the same one for everything. So now there's one other thing I wanted to point out. In the early days of ASCOM, the device makers, the mount makers, and in this case, or focusers, or you name it, whatever, just they weren't interested in writing drivers. Nah, here's how you talk to our LX200 mount, XLM1 £, and then here's how you talk to the Celestron mount, BQLMY. Go away. So what happened was third parties were writing those drivers in the early days, and to an extent they still do. And this is not ideal because you now have two interfaces. You have the standard interface, the universal one from the application to the ASCOM driver, the middle row here, but you have third parties writing those drivers. And then what they're dealing with is a bunch of stuff from the manufacturer that is hard to understand, incomplete, has timing problems, blah, 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 blah. So, it's not ideal. You end up with a half-baked situation, or, and so this was a bad phase, and it is finally in the last, I'll say 7, 8, 9 years or so, let's just say 10 years, the really high quality companies like Planewave, Astrophysics, Mountwise are delivering their mounts with the drivers. And so now if they make a change to the mount, they change the driver, it's transparent to you. Out there in the rest of the world, all we do is talk ASCOM, and we can talk to that driver or that driver or that driver, the old version, the new version, all of that is completely transparent. Now, you're probably asking yourself, how is this possible when they add new features? I'll get into that in a minute. So right now I have a time for questions. There's a lot of conceptual stuff in this, and this was probably the toughest part of the whole talk. So, are there questions that Alex or somebody can forward to me?
Bob, I don't see any questions over on YouTube. Does anyone else here have any questions?
Boy, I've either bored everybody or I've been really successful at explaining this concept.
No, I think
All right,
we're all paying attention, Bob.
this is good. Okay, so now let's talk a little more about interfaces, specifically the ASCOM interfaces. What are the principles on which they're based? And this is another conceptual area that once you understand, it's going to help you. However, this is the most difficult of all of them to understand, and you'll see why. First of all, an interface, a true interface, a modular system interface is a contractual list of elements. So there are objects such as right ascension declination, focus count, exposure duration. Those are the objects. And then there's actions, slew, expose, move. Those things to make up a true interface they're there, they're fixed, their names are fixed, the actions are fixed, the behavior is fixed, and that's really important. When you call a slew, it's supposed to do that, and it is supposed to do that, or if it can't or doesn't, it's supposed to raise an error and tell you why it couldn't or didn't do that. Do it right or raise an error. Vital. That's a very simple concept, but when you see something that you tell the mount to go slew and it doesn't slew, but it doesn't give you an error, it's broken, period. That's just plain broken. Oh, well, just write a loop and call it 500 times. Really? How many times? No. Do it right or raise an error. Anything else, boom, it's broken. So that's something to keep in mind. Now, the other thing, and the next slide's going to get into this a little deeper, is that the actions and objects in the ASCOM interface are strictly for the things we do each night while we're observing routine operations, slewing, turning the tracking on and off, that sort of thing. A perfect mount would slew exactly to where you told it, and it would track the sky exactly without needing guiding, right? Some are better and some aren't. But the point is that there is a set of things, parking, homing, which I actually lost the battle on homing. And if we have time, I'll tell you what I mean by that. Parking, yeah, you need to be able to park the scope, turn the tracking on and off. It's pretty simple what you do every night with the mount. You don't go in and redo the PEC. You don't go in and change the model. You don't do any of that stuff at night while you're observing. You do that when you're installing it, when it's broken and you have to fix it, or you have to do something to, once the hood's open, then everything, you have to do all kinds of things. This is the stuff when the hood's down and you're behind the wheel. That's all that's in the ASCOM specs, and it's by design. I'll get into more of that in a minute. But that's a really important thing to understand. So I have made that point pretty clear. It's a fixed set of objects and actions, and it's the minimal set for successful observing, whatever that thing has to do. And for each object and action, the behavior is very strictly defined, including do it right or raise an error. There are some optional things, actions and items, and you can discover those things, whether they're supported or not, by asking whether it's supported. If it's something that is destructive, such as can it slew to Altaz, let's say. Some mounts don't do Altaz slewing, but you can't find out if it can slew Altaz without trying it. Well, you don't want to have to find out by trying it and having it tell you this isn't supported. So you and getting an error back. So there's a can slew Altaz in there where you can test that ahead of time and find out, yeah, okay, this mount doesn't do Altaz slewing. Okay. But there are other things, like if the mount gives you the GPS coordinates, you can ask the GPS coordinates and that's not destructive. So you can ask and it just comes back and says, sorry, I don't have a GPS. That's cool too. So there is a design aspect there for the destructive things. There's a can uh, object that you can ask before without having to do the action, or there's other objects there are other themselves that are optional, and then you just ask for the object, try to tickle the object and it says, nope, sorry, I don't have that. That's cool. So that's what says some objects and actions for a device type, same objects and actions for a device type, regardless of who makes the device. I hope I've gotten that really through. Now, what do I mean about the behavior? If you look, this is an example of what the ASCOM conformance checker does with a mount. And just watch this thing as it goes through. This is a conformance check. And as you can see, it's extremely for a device thorough. And we can thank Peter Simpson for maintaining this tool. Every time a driver or a mount maker or a driver writer, which hopefully they're the same group, makes another mistake or misinterprets something or does something that is a shortcut, that's usually what the problem is. He puts that in here and then the next release comes out and it checks for that error also. Here's one where I just showed where it shows trying to send you an illegal RA value, and so it checks to see if things are working right. So the behavior checking is very thorough. And if something passes conform, it's probably pretty good. Now, there's one last aspect about the interface design that sort of goes along with this same thing, what I was telling about routine operations only. There are some people who think this is the future. As things get more sophisticated and we get more capabilities, wow, I get more dials, I can change biases and gains and do all this stuff. And yeah, and I could swear it works better this way or whatever. And yeah, I can change the mixture and the spark timing and all this stuff on my car. It's just fantastic. Well, there's a whole nother group philosophy out there that says, you know what, as we get more sophisticated and we learn more about how these things work and they get better and we get better, we can automate it. We don't even have a stick shift anymore in most cars. It's gone. So just think of it this way, that what's sitting here right in front of you with some, with some accessories such as mapping and music and that sort of thing. But you basically have an accelerator, a brake, steering wheel, some dials to tell you your speed and some other things like that, turn signals. That's it. That's the whole interface. That's what you need to operate your vehicle on the road. And that's exactly what the ASCOM interfaces are built or designed for. The stuff you need to operate your telescope during the night and get data. Not all of the PEC and the models and all that stuff. All of that is the responsibility of the mount maker to build tools for you to make that mount more perfect. If the mount was perfect in the first place, it would slew exactly within an arc second to where you told it to, and it would track plus or minus a tenth of an arc second for the whole rest of the night, right? Well, no mount does that, but there's very clever ways that people have come up with to make these mounts act almost perfect, but that's different from one mount to another. So that's not part of the ASCOM interface by design. I hope I've made that pretty clear. Once again, that's another set of concepts that I wanted to get out here before, and we're going to do a little history and then we'll get right into Alpaca. But if there are any other questions.
Bob, some questions have popped up. There are a couple of them, so let me just go through them and you can answer them as we can. The era raised the question. I understand the usefulness of ASCOM. However, why do most vendors still need to implement an ASCOM driver and a native driver?
You got me. I don't know why they have to, unless, if somebody feels there are two things right now that are out there, and I should have put this in there. I don't believe I meant to say up at the very beginning, and I thought I did, that I was not going to cover cameras. And I saw somebody talking about ZWO and all this stuff. The camera area due to CMOS is very fluid right now, and I'm not going to try to back up to that slide, but I thought I mentioned at the beginning, I just don't even want to talk about cameras. It's a mess. Everything else, if a developer or if a company says they want, other than cameras, the cameras, you've got people doing planetary imaging, right? And the ASCOM camera spec will not support video, and that's basically what planetary imaging is. You have a high frame rate and you pick lucky images and that sort of thing. It's not even designed for that. It's designed for single shot. So that's where Sharp Cap and them. So I don't want to get trapped too deep in this, but that's the only area that I know of where people are using native drivers a lot. Everything else pretty much uses ASCOM. There are a couple of small exceptions. One is for rotators. Optech has said that they would like to have the offset between the sky position angle and the mechanical position angle be a property, an object of the rotator, and not managed inside the app. I said that sounds like a great idea. Jared at SGP also agrees that's a great idea. So it will go in. There will be an update to the rotator spec to support that. And for the life of me, I can't think of what the other one is. Oh, in cameras, but I was not going to. Can you still hear me? I'm hearing some sort of beeping.
I don't know. I do have another question for you, Bob.
Okay, great. I'll take it.
Do you have a suite kind of interface where I can see the in-out of all kinds of software running on my machine connected to ASCOM?
Well, there is no ASCOM to connect to. It's an interface specification. So one piece of software is connected to the mount. There's no middle thing. There's no ASCOM in the middle. That's a common misconception. Oh, it's that ASCOM that's broken. No, it's a specification. So if something isn't working, then it's either the application or the device in the case of an app and a device, right? It's either the mount, and I use mounts as an example, but it could be anything, domes, which is another source of pain, but it could be the application or the mount, right? So which is it? And there's nothing in the middle. The application calls through Windows, and then it ends up in the other program and talks to the driver. So maybe I misunderstood your question, but there is no ASCOM, so to speak. It's a specification.
No, I think that's a good answer. One more quick question. Is there a place to see the conformance testing log, or is that something a user would ever see?
Oh, a user is perfectly in their correct to want to see the conformance check for any device they buy. Some of them are online at the ASCOM site, but we don't like the idea of publishing drivers for things on the ASCOM site because they really should come with the device. As I was saying before, there shouldn't be third parties writing these drivers. Some of the equipment is abandonware, and therefore the company who developed these things years ago is not going to write a driver. There's other garage shop type operations and they can't afford a programmer. So then some nice guy comes along and writes a driver for it. But then they come and go and the driver sits out there. There's focusers like this. So, but you can ask for conformance check. And if you go to PlaneWave or with mounts again, if you go to AP or PlaneWave, just as examples, you can get those conformance checks. And sometimes the drivers that are posted on the ASCOM site will have that conformance file on right there with it.
Okay, I think we're caught up.
Okay, so onward. So a little history. How'd we get here? I'm not going to spend much time on this. I already said that back in the old days, we had no standards and we had app developers having to develop incompatible things. What the real key to this is that the barrier to entry to astronomy software was super high because in order to do anything that had to do with mounts, you had to write your own software for every mount out there. impossible. Most people just get the entry barrier was out of this world. So along came ASCOM with the standard nouns and verbs and LPC. I've explained all this. I just want to review it. And so now what do we have with Alpaca? What we're doing is taking those same actions and objects, nouns and verbs, and implementing them using network technology called REST. I'll talk a little more about that. And all of those other operating systems out there support REST. And every language has REST libraries. Every language you've ever heard of. Well, I'm not sure. Maybe I'm a little far out there. I bet you MATLAB doesn't have a REST library. It might. Who knows? But anyway, most of the other ones do. So now, how well did we do over all these years? As a result of some, we'll call it acrimony earlier this year, it was really a wake-up call for myself and Peter and Tim and Daniel, and to just check how are we doing. You know, there was some talk. Well, I'm not going to go into how all that worked, but anyway, it served as a wake-up call and resulted in my doing a survey of 52 app and device developers, and that the raw data for that survey, the link on the bottom, you can go to the ASCOM site and find all kinds of stuff there, and the data from that survey without names is available there, so you can see the questions and the answers and the numbers. But the key piece of info here is that 100% of the people we surveyed, and these are both application developers and device developers, say they see ASCOM taking them into the future. You'll hear people saying, that stuff's ancient. It's no good no more. Nope, sorry. It's that it is highly well proven to be suitable and applicable, and people see it taking them into the future. So that was the key. And the whole point of the survey was to prevent people from having a knee-jerk reaction and then changing the game completely just because someone says we're all stupid. So fortunately, we did that survey, and people came back with a good answer. You can look at the other stats there. Alpaca's already pretty well known. And so I would call that a big success. On top of that, you've probably heard of Stellarium. It's been around for 10 years or so. Alexander, I can't remember his last name, in Russia, wrote it, and he's been working on it free. It's a great program, but he has really resisted putting ASCOM in there. And I contacted him a few times. He's like, never mind. Okay, well, so. But it runs on Windows, and Gian, this guy, built a plugin to give it ASCOM compatibility, and that you can see this is on Cloudy Nights. You can see that right away, and this is the title of it. And I would say if you want to have some fun, look for Stellarium Direct ASCOM Support Testers Wanted. Look through that thread, and you'll see how pent up the demand for that has been for Stellarium. And I just call your attention to the one from just a couple of days ago. Gian, you've made a great contribution to this hobby. Fellow amateur astronomers everywhere will appreciate your efforts. Thanks for this serious improvement. So anyway, all I can say is that ASCOM has been very successful, and this is where we are now. Now we're about to hit the Alpaca. So if you guys are getting bored, stick around, man. This is the best part. So, but I have a 5-minute question period here, and I'm just a little over 35 minutes right now. So I'm running right on time.
Bob, the one question came up. Let me just ask it as it's written. Let's see. Can the Alpaca driver machine be non-Windows like Ubuntu?
Hit me. I was looking to see if I could. I haven't gotten into the Alpaca stuff at all yet. I think that'll answer your question, actually. But say that one more time, and I may just say, stay tuned, I'll answer it.
Okay. Can the Alpaca driver machine be non-Windows like Ubuntu?
What? I have to read it. Alpaca driver machine, did you say?
I'm reading it as it's written. I'm not sure what the question is,
Bob,
other than
Bob,
reading it.
Bob, the way I understand the question, I think we best just hold off because I think the answer is, duh, the whole idea is that it is pretty much operating system independent.
That's right.
So let's just hold off on that.
That's the whole point of it. Right. Okay. So here we go. What is Alpaca? And I think I've hinted at it before that it is the same interfaces, all those same interfaces, but instead implemented as REST endpoints. And REST is representational state transfer. I'm not going to get into all the technical stuff. What it is, it's a network protocol for making calls across from one thing to another. So instead of going through Windows and LPC, it goes across a network connection. Even on the same machine, you're connecting using the operating system's network interfaces, network transfer stuff between programs and also between programs and devices. That's important. Or their drivers, I shall say. The driver may end up talking over God knows what to the device. But the point is, the standard stuff, those standard calls are all over REST. There are no servers or special libraries. REST does require the device, the responding end, to have a little HTTP responder. That's the way REST works. But these things run on Arduinos and tiny little things, so they're very lightweight. Anyway, the point is, it takes those Windows interfaces and implements them on all these other operating systems. Now, this is a key slide. Try and stay with me here. The yellow block in the middle is here today, and it serves as a two-way gateway between the COM LPC ASCOM, classic ASCOM, and Alpaca. So, for example, I don't know, can you see my mouse on this? Can you see me moving the mouse around?
Yes, we can see the mouse moving around.
Oh boy, I should be using this more. All right, here's the sky, and it speaks classic ASCOM. It's on Windows. This the you can see the Windows logo here to the left of the dotted line. So it speaks classic ASCOM, unmodified thing of the sky. By virtue of ASCOM remote, it can now connect to an Optec focus links, which is a self-contained Wi-Fi focuser using Alpaca. Nothing in between. There's no servers, there's nothing. So this focus link box is accessible from an unmodified copy of the sky. You don't have to add anything to get to Alpaca. It goes through this ASCOM remote gateway. So that's one half of the equation. But here's another one. Patrick Chevali, and same with Klein, Klein. And maybe, well, and then because of Gian has written this now for Stellarium, that's 3 planetariums that now can speak. Well, that's incorrect. The last one speaks classic ASCOM. So Klein and Patrick Chevali have already added Alpaca to their planetariums that run on Linux and OS X. So by virtue of that, they can connect through this same gateway, but now in the opposite direction, and use an astrophysics mount that's being controlled on a Windows system with APCC and all of it. So you could have a little box up there with your astrophysics mount, APCC, and it's accessible from at least 2 planetariums already on Linux. That's today. That's not, future stuff. So ASCOM Remote's an important piece of migratory software. It's free. You just download and install it. It's actually quite lightweight. And my little demo, which you can see the video of that on the ASCOM website, shows the sky running a rotator simulator on a Raspberry Pi that I wrote in Python. And so there's effectively a self-contained rotator with a Wi-Fi interface on a $25 thing that can be controlled from the sky by virtue of the Sky's native or classic ASCOM, going through ASCOM remote, and then back out Alpaca to the Pi and the rotator simulator. Excuse me. I'm going to cough one more time. Okay. So that kind of gives you maybe even a better idea of how all this stuff works together. Now, let me make a point here. And this is what was really a problem last spring, and I didn't understand that this was a concept that was circulating around. What I show here is that all of these operating systems can talk to each other with Alpaca, right? But you do not need Windows. That's not part of the equation. The ASCOM remote is middleware that lets Windows reach out and receive from the Alpaca world, but it is not necessary for Alpaca to operate. So that Raspberry Pi, which represents a rotator, would be able to be used from any software on any of these operating systems by just making the Alpaca REST calls, and that's it. So the whole point of this is to make it independent of Windows and also cross-platform. And as I said, the languages that are out there all support REST. So now, I don't think any of us would disagree that the USB is a universal source of pain. It's probably USP, it should be, right? Especially with the habit of Windows turning the power off and selective suspend and all this stuff. Ugh, it's awful. So imagine a world with no USB. That would be cool. Self-contained mount with a Wi-Fi thing on it, or anything else, really. So the protocols are very lightweight. The Alpaca protocols, they're easily implemented. I showed you the Focus Links box. That's got some microscopic processor. Daniel, who wrote the Alpaca for that, it's in C, and the thing has no memory. And anyway, it can run on very small, lightweight, cheap processors. So it's not a dream anyway. But imagine no USB. It would be really cool. And that's another goal there. One last thing. It's a concern, of course, that if this stuff's working over the network, what about security? Shouldn't you have passwords, usernames, SSL, all this stuff? And excuse me. And the answer is, after looking at it, it's a slippery slope beyond belief. So we talked to government. There are several big government labs that are looking at Alpaca, one in particular that we talked to, and several universities. And the answer is, yeah, we keep these things sterile. We air gap the networks in there. We don't let this stuff, the instruments to the control software, out over the public internet. And it's not a good idea anyway. But if you insist on doing that, the way to do that is either to set up a VPN or to use a proxy. Since this REST is basically HTTP based, it's going to be complicated, but you can then have all of the OAuth and SSL and all that stuff out in the nasty public internet, and then come back out on the other end. The VPN is probably the more practical solution, but usage patterns, I don't see a whole lot of people running this stuff across the connections between their planetarium and the mount, or SGP and all the instruments and stuff. I don't see them putting the instruments in the Sierras and running SGP locally with all of the Alpaca, the instrument stuff going over the internet. That's just not a good way to do it. As an interface, it's bad. It's bad design. So the whole thing should be within the observatory. Then you don't depend on the net anyway. If you lose your network and the thing's working, it keeps working, right? So anyway, that's another issue. So now I have another Q&A period, And I hope I have more questions because now I've really covered it all, and except for the status and what's next. So let me look at what's on YouTube, unless you guys have already spotted a question that. Did I answer the magic question about the alpaca on Ubuntu? I mean, the
Yeah,
answer is,
the person on YouTube said that the question was answered. So
oh, good.
is there anything for an average user to implement for Alpaca, or is it up to the manufacturers and device and software people to do it?
There's nothing for an end user to implement. This is plumbing. What you guys deserve is to be able to um, install this stuff. And there is a discovery protocol coming, and I'm going to talk about that in a minute, which will give you, within that sterile environment, it will tell you, let you select different devices. So it's kind of like the chooser you have in ASCOM now, only it's smarter than the current ASCOM chooser, which you can blame me for being too stupid to have two focusers of the same type. It doesn't support that, and that goes back a lot of years. So I'm the guy who built that in. What?
How is place handling transfer of large binary data like images?
I didn't understand that. I'm sorry, Eric.
Let me just read it. Bob, how is, I think she meant place, she says palace, handling transfer of large binary data like images?
Like I said, I'm not going to talk about cameras because it's in flux. And I will say one thing, and that is, in a distributed environment like this, where you don't have a hardwired thing like USB from the camera to the computer, the CMOS cameras, which is where this is coming from almost certainly, will have to stack in the camera. They're going to otherwise, if you want to take this already came up with AAVSO. Somebody wanted to take like 60-second images, and they were going to have to take 20 of them because of the brightness of the star. And they were big cameras. So that means you had to transfer this enormous amount of data from the camera and then stack it on the PC or whatever. And yes, there is software that does it, but back in the old days, just to put things into perspective, who remembers the old SBIG cameras that had no frame buffer in them, and you had to saturate the CPU. You could not use the PC for anything. No multitasking. If you did, you had to do it at a high priority. If you didn't do that, you would get horizontal banding because the image would shift off in chunks, and it would continue to dark, would build up, and it was horrible. And for the lack of a little bit of buffering money in the circuitry, it created tons of pain for people. ACP still has internally, when it's reading the data from the camera, it still shuts itself completely down as far as the web and the displays and everything else. It doesn't read weather. It doesn't do anything. It actually freezes and lets the image transfer directly from the camera into the buffer on the PC, because I don't know if I'm dealing with an unbuffered camera. It's horrible. So, and that's now 10 years since, ages. So by doing that, it created a legacy for years and years and years and years and years. And I'm on a real tear with regards to cameras to prevent that and from happening on CMOS cameras, where of course, you have to be able to do that when you're planetary imaging or doing so-called lucky imaging. Yeah, you've got to, but that's a video issue. That's really video. You're transferring lots of frames at a high rate, lossless, so it's tough. And I have talked with someone recently who claims to be an expert on that, and I don't know if he's going to come back and help us on that or not. None of us know how to do that, so maybe somebody will. But that's a big problem. But like I said, I want to stay away from cameras because it's a time sink, and it's the whole technology's in flux. And I expect that in the near term, I pray to heaven that these camera manufacturers will see the light and stack these things on chip, and that they'll also somehow adaptively set the bias and gain and all that other stuff. Either that or used readout modes where you can set up a bunch of different readout modes and then select what characteristics you want for your camera and stuff like that. I don't want to talk any more about cameras. I hope whoever asked that question, at least you got an idea that we're not just blind to the problem, but that we really don't know what to do with it right now because
there's some discussion going on. What's the current, have you covered all the current state of implementation of Alpaca?
Not quite yet. Hold on. Right now, the specs are done. People are free to implement the protocol inside their apps. It's a chicken and egg problem, right? We've got some chickens, now we need some eggs. So the specs are all sitting out there. The missing piece for people implementing are the discovery protocol, which I'll get to in a minute. But here's where we are right now. So you asked me the question. Here's the next part of the talk. So the specs are out there. There's a simulator, a Python example, and someone who's much better Python programmer than me, which would be just about anybody, should be able to implement whatever they need to do. And that's on any platform, right? And so we have some Optech focusers, Carte du Ciel, Hello Northern Sky, and here's a good story. At one of the large universities in Southern California, they ripped out the Astrohaven control system and put in a kind of a fancy industrial controls type of system for the whole observatory to include opening and closing the clamshell. And all of that was done with off-the-shelf, industrial control software and hardware. What's that? I don't know. Anyway, it's the stuff they use in factory automation. And the guy who did that wrote the Alpaca driver, the Dome driver for that in 5 hours from seeing it and talking to me on the phone. He called me up that night. He says, okay, it's done. And it works great because he's using it through ASCOM remote. And so any software running on the Windows system there, mine included, can open and close the clamshell as though it were just any other clamshell or dome. So it's out there. It's just a matter of people, the developers, sinking their teeth into it. Why did that ding? Discovery. That's one of the things right now. In order to get all these things to talk to each other, you have to enter IP addresses and ports. Most people are familiar with that, but it is, not too cool. So there is, it is pretty much finished. It's been written and implemented on all the devices you see in this list. In other words, a lot. And by the way, the .NET Core is good for all the operating systems. I did it in my rotator simulator, the Python rotator simulator. I think it took me 12 or 13 lines of code for the whole thing to respond to a discovery broadcast. So it's extremely lightweight. We've been criticized for that, but again, it's a sterile environment, and this stuff has to run on nothing and be easy to set up and not require a lot of network administration. And this is super lightweight, and it works great. So what you'll see as a user is you'll open up a thing that will list all of the equipment that you can see within your local network. And so if you have 3 focusers, you'll be able to pick among the 3 or whatever, or pick your mount, and that whatever's out there will answer. So it's even better than the chooser for Windows, which lists all of the drivers that are installed. The discovery mechanism for Alpaca will only list those things that are actually alive. So you'll just see the stuff that you have installed on your local network, which is kind of cool. So what's next for all this stuff? There is a pretty big, I'll say more than a pretty big effort to provide tools for application and driver writers to do things cross-platform. This is, It's not really part of Alpaca. It is a part of the ASCOM platform and ASCOM tools effort. When I say ASCOM platform, again, I want to stress that there is no ASCOM that everybody talks to. That's a set of specifications. However, there are tools for developers, templates, libraries, things like that to make it easier to develop software that operates in that environment. But that stuff goes inside the application or inside the driver or the equipment, the self-contained mount, whatever. There's no middle thing in there except ASCOM remote, and that's just a gateway from one technology to another. I want to make sure that everybody understands that. And if I've not made that obvious, shame on me. So but separate from all of that, all those tools, there's an effort being made to make those portable to other operating systems. So people on Linux and on OS X and other operating systems can develop drivers and actually target both Classic COM and Alpaca within the same driver if it's running on Windows, and then take that same driver, the driver code itself, move it over to Linux, Ubuntu, whatever, and only have the Alpaca. It's a building block approach. It's actually quite clever how that's going together. It's made more complicated by the fact that Microsoft is in transition with .NET from being a Windows-centric to a yes, everything-centric company. They really shot themselves in the foot badly a couple of months ago with a bad Windows update, which of course brought all of the Windows haters out. But they're trying and they're doing, anyway, I'm not going to get into OS wars either. Sorry. And I don't love any OS. Don't get me wrong. I'm the guy who ported GNU Emacs to the early Apple AUX operating system. So I've been around. Anyway, the whole thing is being done to try to make it possible to take a driver and move it from one platform to another. That's a different problem than communicating between applications and devices. So I don't want the two to get conflated. But there is an effort there to help people on other platforms participate in the Alpaca environment, to tools and developer libraries and tools that will make it easier to develop drivers and so forth. So that's happening, and that's going to be probably early next year before that is completely there. All right. We are now a little over an hour. I've just about hit my hour right on. It was started 10 minutes after, at 7:40, and I'm now at 8:40. So that's cool. And I would like to take any other questions and comments, and I'm happy to talk here now. I'm yours now for as long as you want. I'll stay here all night.
Thanks, Bob. It was a pretty informative discussion, pretty much conceptual for many of us. I mean, if we've got a system that works now, as long as we don't change anything, it works. But I know that it works for the past and for the present. We don't know what's in the future, and we do know that we're going to need something in the future. But let me ask you, what's the difference between the Alpaca approach and the Indy approach?
All right, I'm going to go back here and put this slide back up and simply tell you I want to take this offline. I'm not here for a standards war. I'm not getting trapped into that. That isn't, okay, so what's an equivalent question? What's the difference between Windows and Linux? Or what's the difference between Python and C++? They're all flame bait, endless discussion, religious issues, and I'm not here for that. Sorry.
Okay, thank you.
Bob?
Yes, sir.
When do you think we might have some trickle-down effect from the implementation of Alpaca? Or is it already happening and we just don't know it?
How can you help? Didn't I put this slide up? I think I skipped it. Whoops, I did.
Yeah, I was going to ask about that one.
Well, right now, if you happen to be running on Linux, you already have trickle down, and that is you can talk to plane wave or astrophysics mounts running on Windows. That's already trickle down. Um, that's a beginning. Just to put things into perspective, with me starting in 2009, it was probably 5 years before it started to really become a standard 15 years ago. So it's not going to happen overnight. The last bullet says that give this technology to become, but how you can help is to encourage the app and device developers. You are their customers. They're, this is how they deliver their user experience to you. If you have something that you want, tell them. If you're happy with what you have, then this probably won't impact you. But if you want something else, and it has to be concrete, the thing is, there's all these all these preachers out there having all kinds of sermons about this, that, and the other thing. This is bad. This is old. This stuff is trash. This is what the world's going to now. And I've been through so much of this stuff as a developer. I, I've been developing software continuously since I was 17, and I'm 73. Add that up. And I mean it. I'm the whole damn time. My first computer was an IBM 1401. And I never did micros either. It was all minis or controlled data, DEC. Digital was a big one for a long time. But I did bite on the Mac in 1984 and got involved in that, and that was a whole nother thing. So I lied. But I never got involved in all of the 8080 based stuff. So, but there's all these people out there with all kinds of things to say, and you can be made to think that there's magic that's coming and all this stuff. If you have something you want, let the people you trust know what it is that you want. And that's how it's going to happen. This is really a business driven thing. There are some groups of people who do open source software, and there's some phenomenal things that have been done that way. And, but if you have a problem and you've got 50 or 60 or $100,000 into an observatory and you need answers, yeah, well, there could be an issue there. So there's a whole spectrum of people, hobbyists, makers, people who are very knowledgeable technically, people who a high school teacher who just wants to do astronomy with their student, and there's all these different people. And the way to make it happen, if you think that there's something that can benefit you and that you need to have access to, then that's the way to make this happen. And Alpaca can run on Windows, within Windows too, but it doesn't really provide much more than what's there now. So on Windows. And the second bullet on this is there's one thing that I have avoided and has allowed me to survive for all these years as an app developer, and that is I have steadfastly refused to create software victories over hardware. And Jeff, I don't know if anyone remembers Jeff Metcalf. He's passed away now. He was an amazing guy. He and Dave, I can't remember his last name, of the Junk Bond Observatory down in Southern Arizona. This was years ago. He coined that phrase, and it's right. I've refused to do that. If there's a problem with something, I am not going to get involved in trying to create a fix. And here's why. The minute I say, yes, I will do something to make up for the fact that you have to call your mount to slew 50 times, and then maybe it'll slew, the problem's mine. It's not the mount maker. I now inherited all this bad problem, and I know nothing about the inside of the mount. I don't know if they're going to change the firmware next week. I don't know anything, and now I'm part of the problem. If I had done that over the last 20 years, I would be in my grave. So don't ask the app developers to put timeouts and checkers and retries. How often do you retry? How long do you wait before you retry? You don't know anything about this thing that isn't acting right. So if a good app developer is going to come back at you and say, you know what, you paid ABC money for this mount. It's supposed to act this way. It's supposed to work according to the spec and behave the way ASCOM says it's supposed to behave. It's not. Go to them. You paid them the money. So that's another thing you can do to help, although it has nothing to do with Alpaca. So I don't know. That's just two things that I wanted to throw in there.
Alex, I think we're good.
Did he disappear?
No, he probably doesn't have his mic turned on. He'll be here in a moment.
Okay.
Okay,
Let me
so
look at
if
YouTube. Hang on.
if we're good, we'll say good night, and we'll see you guys next week with Robert Vanderby. He's going to explain to us how he creates HR diagrams using our data. For instance, like him and I, we did a collaboration with M13. Might talk about that, and we'll see you guys next week.
Okay, thanks
Okay.
very much, Bob. Excellent talk.
Thank you very much. And I see some comments about security further up in the comment stream questions, and I hope I answered that. And yes, the sterile environment means no communication with the outside world, not only behind a firewall, but even more so than that. So, and that's the way the universities and government and observatories and whether, operate. So that's it. And it is for that purpose. So there you go. Thanks, everybody. And let me shut my screen off and at least say goodnight to people a nice way here. How's that? Hello. Good night, everyone. Thank you very much for listening to me and looking at this. And if you have any questions, you can write me at rdenny@dc3.com. I don't answer email that quickly, though, but I'll do the best I can. Thank you.
All right. Good night, everybody.